What is going on, everybody? Welcome back to another Fusion 360 tips and tricks tutorial. For those of you who don't know, my name is Adam James. I am a plastics engineer with years of experience using CAD engineering software. In this episode, I'd like to outline how to properly import a mesh, say an STL file, into Fusion 360 to be able to use it as reference to measure points that you can then modify to 3D print maybe a remix of someone else's design, right? So sometimes, for example, on thingiverse.com, you will be presented with an STL file of a cool product that maybe you want to actually 3D print yourself and use, right? But the problem is typically what those designers or engineers upload is an STL file. Now, an STL file contains geometric dimensions, but it doesn't have design history. So you can send it's basically a bunch of triangles, and you can send that STL file to a slicer and create a G-code, right? But in terms of modifying the geometry, it's a little more difficult, and it took me a little bit of time to actually understand how to properly incorporate an STL file into Fusion 360 with correct dimensions. Now that's what I'm going to go over today. So with that being said, let's jump over to Fusion 360 and we'll outline how I properly go about a workflow to grab those dimensions, which then I can use to create my own Fusion 360 file that's modifiable for future projects, right? So here we go. So I'm working on this top 5 most useful 3D prints, and I came across this mounting clip. If you can hear, there's a 3D printer in the background that's actually printing out some of those components. But this mounting clip is an STL file that I grabbed from Thingiverse, and once you import it to Fusion 360, sometimes the dimensions aren't correct. So I'll actually go and do this live. So we just have a new design. I would like to, this is how you would typically upload a regular part, right? You go up to the top left, you'd go upload, select file, and we're just going to grab this mounting clip. Click open, and we'll do upload. I have access to this file, and I'll just take some reference dimensions. Now, with that being said, the reason I like to take reference dimensions, it's kind of like using a tape measure, right? You're not getting an exact dimension, but you're getting something in the ballpark that you can kind of remix and modify yourself. With tolerances and super, super tight geometric assemblies, this is not the way to go. It's nice to get reference dimensions for something as simple like a 3D printed plastic part that you can modify yourself. So we've got this STL file in here, and I know how big this is supposed to be because I have the part and I've already 3D printed it. But you should already typically know what your reference size should be in relation to the project you're working on, right? This is a clip, but essentially what I wanted to do is I wanted to extend this to go over it's a shower door, right? So to go over a shower door, and to do that, I need to modify this width of the frame. Pretty easy. So what I wanted to do was I wanted to bring this STL file from Thingiverse and then recreate it in Fusion 360, so then I have modifiable geometry and I can use it in the future and modify it to my own shower door. Cool. The problem with the workflow that I just went through is I know that this little circular diameter hinge that attaches to this frame is about, I don't know, no more than 2-3 millimeters. But as we go and measure, just as reference, right, we can click 2 points on this STL file on the right view. 45 millimeters? Yeah, I don't think so. So the workflow seems to work fine. But for example, when say we were to then 3D print this. We'll click OK. We'll do clip example. Let's bring it into Cura here. Unless I closed out of Cura. Guess we gotta wait. Okay, so once we open Cura, what we're going to do is grab this clip example, bring it in, and just for reference, I believe my bedside is 8.5 by 8.5 inches, right? Not huge, but this is going above and beyond that for this little hinge, which is supposed to be maybe no more than 2-3 inches, right? So let's go back to Fusion here. Something's going on. New project, or new part rather. And so we tried upload. Well, you're probably saying, well, maybe your units are off, right? Well, could be. Okay, so we're in millimeters. Let's try inches. Do that. Just the mounting clip. We'll do OK. Upload. Now, the thing about actually going this route is it's uploading to its own separate component. So it's not it uploaded another mounting clip to a different its own separate identity. So we're not actually in the component untitled one. If we click on this, it will open a separate window. So changing the units within your workspace and then doing the upload button essentially changes nothing, right? Which is kind of interesting because we are still in millimeters, right? But say we were to change this now to inches yet again, and we go to inspect. And it says the gap in between this diameter is 1.8 inches. I think not. So here's the solution. Within Fusion 360, it's particular in the sense that when you have a design, you want to save it. Let's call this clip example 2. We're in clip example 2, and instead of uploading your part like you typically would any other CAD file, you go to insert. So you want to treat STL files, importing STL files within Fusion 360 such as you would importing, say, a decal, right, or a logo. You want to go to insert, mesh. Now, I really wish from the user interface perspective they would have gone insert STL or insert, maybe even have a separate button for insert STL. I don't know. It took me a bit to figure this one out. So we'll click on mounting clip.stl, our original one. We'll do OK. And now we've got this mesh in the bottom. So let's go to our right view. Now we were getting, I can't even remember, 45 millimeters? About 1.8 inches between this gap. So let's see where it is now. 6 millimeters. Now that I could believe. So we know that's about 6 millimeters. Now let's double check. We can 3D print this. Click on this, select OK. Clip updated. Let's open back Cura here. Get rid of this guy. Let's open clip updated. Boom. So those are indeed the correct dimensions, and we can, come on Cura, let me zoom in. And we can now reference those in Fusion. So for example, go back to Fusion. I can measure the distance between this diameter. I can measure, say, a reference thickness. It's about 2.6 millimeters in thickness. So what that allows me to do is, following that workflow, to correctly import the right scaled geometric dimensions from this frame that somebody else had created on Thingiverse, to then create in Fusion 360 and extend and relate that geometry to my own personal remix, right? So this is essentially that remix. I extended the frame. These are the same diameters that I referenced. Now, the purpose of this is not necessarily to eliminate using a caliper, right? If I already have the part in hand, it's much more accurate to take, say, a caliper, measure these dimensions, and then whip up a CAD remix. But what this route does is it saves a step, right? So what you can do, without having to 3D print these, or needing a 3D printer rather, you can take those STL files from Thingiverse, bring them and insert them as a mesh in Fusion 360, and then you can take reference dimensions using the measure tool within Fusion 360 to eliminate. I mean, this print took, I want to say it took like a day, like 24 hours. So if you want to remix your, say, frame width for this example, then you could go through this route, measure the dimensions based on the STL file, and then create a modification, and then 3D print this component and your updated frame width without having to wait and use calipers to measure the final 3D printed component. So I hope that helps. If you guys found this useful, be sure to like, comment, subscribe, and I will catch you on the next one.